Welcome to All Things Quality, the channel that helps you transform your quality knowledge into powerful, real-world impact. In today's episode, we're introducing a game-changing tool for optimizing performance, solving tough problems, and uncovering hidden process interactions. Design of experiments, or DOE. Whether you're working in manufacturing, healthcare, R&D, or service industries, DOE can help you go from guessing to knowing. From trial and error to statistically sound decisions. Let's break it down step by step, so you can start using DOE to design better processes and deliver better results. Design of experiments is a structured approach that lets you study the effect of multiple input variables called factors on an output or response. Rather than changing one factor at a time, DOE allows you to test several factors together so you can understand which ones really matter, how they interact, and what settings produce optimal results. It's like conducting a scientific experiment inside your own process. For example, imagine you're baking cookies and you want to optimize taste. Instead of changing sugar level, then baking time, then temperature in separate trials, DOE lets you vary all three together in a planned, systematic way, then shows you how each one affects taste, individually and in combination. Why not just change one variable at a time? Because real-world processes are complex, and factors don't work in isolation. With DOE, you can do the following. Speed up experiments. You get answers faster with fewer trials. See interactions. DOE uncovers cases where two variables combined behave differently than when acting alone. Optimize results. Find the sweet spot for your process settings. Reduce waste and cost. Fewer tests, better decisions. Build robust processes. DOE reveals what matters and helps you design systems that are stable, predictable, and scalable. In short, DOE helps you solve problems smarter, faster, and more confidently. Before we build a DOE, let's cover 5 core terms you'll need to understand. Factors. These are the variables you want to study. Think machine speed, temperature, or pressure. Levels. The settings you'll test for each factor. Typically low and high, though more levels are possible. Responses. The output you're measuring could be strength, weight, defect rate, or even customer satisfaction. Interactions. When the effect of one factor depends on another, this is where DOE shines. Identifying hidden influencers. Replicates. Repeating the same test to account for natural variation. When you put all of these together in a matrix of test combinations, you have the blueprint for a designed experiment. Let's bring this to life with one of the simplest and most effective DOE structures, the 2 to the power of 3 full factorial design, or 2 cubed full factorial. Here's what that means. The 2 indicates each factor has 2 levels, a high and a low setting. The 3 means you're testing 3 factors. So, 2 cubed equals 8 total experimental runs. This tests every possible combination of the factor levels. Here's what the 2 cubed matrix looks like. Let's say we're trying to improve the quality of a sealed food package. We choose 3 input factors: sealing temperature, low or high, dwell time, short or long, and pressure, low or high. Each run tests a unique combination of factor levels. You measure the response, say seal strength or leak rate, and then use analysis tools like main effects plots and interaction plots to determine which factors are most influential. The beauty of this design is, it's simple, powerful, and statistically balanced. You don't just learn what matters, you learn how things work together. There are different DOE structures to match your process complexity, resources, and goals. Full factorial designs. This is like the 2 cubed example, but tests all combinations. Best when you have a small number of factors and need full insight. Fractional factorial designs. Tests only a carefully selected subset of combinations. Great when you have limited time or want to screen for critical variables. Taguchi methods focuses on designing for robustness. Helps ensure performance is consistent even with noise or variation. Response surface methodology. Used when you already know the important variables and want to fine-tune for optimization. Ideal for nonlinear problems or finding a sweet spot. Choose the right design based on your objective. Are you screening, optimizing, or robustifying? Let's revisit our packaging example. After running the 8 DOE trials, here's what the quality engineer finds. High pressure and long dwell time reduce leaks. High temperature improves sealing, but at too high a level it distorts the package. Most interestingly, pressure and temperature interact. If pressure is low, high temperature doesn't help, but if pressure is high, high temperature greatly improves strength. Without DOE, this insight might have taken months of guesswork. Instead, the team makes data-backed changes, sets pressure to high, uses moderate temperature, extends dwell time slightly. Result, 70% reduction in leaks, better shelf life, and higher customer satisfaction. This is DOE at work, practical, evidence-driven improvement. To summarize, here's how to run your own DOE. Step 1. Define the problem. What are you trying to improve? Step 2. Choose factors and levels. Start with 2 to 3 variables you suspect affect the outcome. Step 3. Select the design. Use full factorial for simplicity, fractional if you need speed. Step 4. Build the matrix. Lay out the combinations using software or templates. Step 5. Conduct the runs, maintain consistency, repeat runs to verify. Step 6. Analyze the results. Use software like Minitab or Excel to generate graphs, p-values, and interaction plots. Step 7. Implement and sustain. Apply the optimal settings, document changes, monitor performance. With practice, DOE becomes one of the most powerful tools in your quality toolkit. Design of experiments isn't just for statisticians. It's for anyone who wants to improve a process intelligently and efficiently. Start with small, well-designed experiments. Learn from the results, and expand from there. The next time you're faced with multiple variables and unclear outcomes, don't guess. Design the experiment, learn from the data, optimize with confidence. Check out our other training videos in this series where we continue to delve deeper into the 6 pillars of total quality management, as well as tools, benefits, and how to implement TQM in your organization. Thank you for joining, and don't forget to subscribe for new videos from All Things Quality.